So now we're ready to start working on a very fundamental kind of problem where we convert uh, radians to degrees, degrees to radians. And our first exercise here, so this is actually exercise number 3 in section 7.1. So our third exercise since we started 7.1. How many radians equal 20 degrees? Now, I'm going to give you two totally different ways to approach this problem. I'll call them method 1 and method 2. You only need to choose one of these. You don't need to use both. And just pick the one that seems to make most sense for you and stick with it. I can't decide myself whether one or the other is better. I find some students like method 1, some like method 2, so I'm going to give you both. Method 1 involves setting up a proportion. I really like proportional thinking because setting up a proportion, if you know quantities are proportional, you can often set up an equation without having a formula memorized so much. Now, in this problem, we're trying to find out how many radians, right? So I'm just going to write down x radians. And we want to know how many radians equal 20 degrees. 20 degrees. I'm just going to write out the word degrees instead of the symbol. Now, to set up a proportion, I'm going to divide both of these on both sides by a relationship that involves the same units that we know. A relationship involving radians and degrees that I know. And somewhere along the way, on our yellow card, we wrote down that 180 degrees is pi radians. That's the relationship I'm going to work with here in the proportion. That's one I know. That's sort of my base or my fundamental relationship. Now I have to write radians first to be consistent in the proportion, so I'm actually going to write pi radians here and 180 degrees here under the 20. And the fraction x radians over pi radians has to equal the fraction 20 degrees over 180 degrees. These quantities got to be proportional to each other. So now I can remove the units. I just have x over pi equals 20 over 180, and I'm going to solve for x. And so setting up a proportion, I think, is pretty cool once you get the hang of it. And here I can solve by multiplying both sides by pi, or pi over 1. And I have x is equal to 20 pi over 180. I want you to reduce that. And let's see, if we reduce that, we get 2 pi over 18 or pi over 9. Now we are looking for radians. I'm going to write radians here. So that's the radian measure for 20 degrees. Pi over 9 radians equals 20 degrees. Now we're going to see that pi symbol a lot in radian measure. And it really, pi is just some number like 3.14, etc., right? In fact, this is not like a ninth, right, of a radian. Pi is like 3. 3/9 is approximately a third. This is approximately 1/3 of a radian, really, because of that pi number. Now, I could get a decimal by actually taking pi here on my calculator and dividing by 3, or I'm sorry, pi divided by 9. Pi divided by 9. Pi divided by 9. And I get about 0.349. So radians can be expressed as decimals. But often in this course we're going to see a lot of exact values that involve the pi symbol. So we don't need the decimal here, but I just want you to have that to compare to. Okay? All right, so 20 degrees is pi over 9 radians. Now let's look at method 2. Method 2 involves multiplying by a ratio that is equal to 1. And it's going to be either pi radians over 180 degrees or 180 degrees over pi radians. If you've ever dealt with unit analysis in a science class, you may be familiar with this type of method. Now, pi and 180 are two different numbers. So if I just write pi over 180, that's not really equal to 1 by itself. But if I say attach the units, pi radians over 180 degrees, those are equivalent angle measures. So with the units included, those fractions are equal to 1. So the way this problem would work, remember, we're still converting 20 degrees to radians, right? So I start out with 20 degrees. And you can write it over 1 because we're going to have fractions involved here. And I want to multiply by a ratio equal to 1. I want to pick either one of these two. I want the degrees to cancel. So I want to pick the fraction here. Because 20 degrees has degrees in the numerator, I want my 180 degrees in the denominator. So degrees cancel. And then I have to write the pi radians up above. So I don't want to use the other fraction because I'd have degrees in the numerator of both. It wouldn't cancel out. Okay? And so using unit analysis here, I get 20 pi over 180 just by multiplying. Again, the degrees, I'll cross these out in red, cancels out. But the radians doesn't go away. The radians stays. And there it is. I can reduce that to pi over 9 radians. You can write RAD for radians. So that's the same answer as we got using method 1. Method 1 or method 2. Either way, you can choose to do this conversion.